How did dinosaurs actually go extinct? Imagine a world that had ruled Earth for 160 million years. Giant creatures walking across the forest, massive predators ruling the land, an ocean filled with reptiles larger than most modern whales. And then, almost suddenly, in geological terms, the entire world disappeared. There is no warning, no gradual decline, just extinction on a global scale. So the real question scientists have tried to answer for decades of years is, how did dinosaurs actually go extinct? And the answer is not simple. It is one of the most dramatic events in Earth's entire history. To understand extinction, we first need to understand what Earth looked like at that time. Around 66 million years ago, dinosaurs were not struggling to survive. In fact, they were highly successful. Different species occupied every ecological niche. Large herbivores like Triceratops fed on vegetation. Apex predators like Tyrannosaurus rex controlled the food chain. Flying reptiles dominated the skies. Marine reptiles ruled the ocean. The climate was generally warm and ecosystem was stable. In simple terms, dinosaurs were not on the path to extinction naturally. So something external must have changed everything. The asteroid impact. One of the strongest scientific explanations comes from evidence of massive asteroid impact. Around 66 million years ago, a space object estimated to be about 10 to 15 kilometers wide collided with Earth. The impact site is located near present-day Mexico, forming what we now call the Chicxulub crater. This is not speculation. The crater, shocked quartz and global iridium layer found in rock sediments all support this event. But what actually happened after this event? The energy released was unimaginable, equivalent to billions of nuclear explosions. Immediately, shock waves spread across the planet. Earthquakes occurred globally. Mega tsunamis hit coastal regions. Wildfires spread across continents. But the most devastating effects did not happen instantly. They happened afterward. After the asteroid hit, enormous amount of dust, ash, and sulfur particles were thrown into the atmosphere. These particles forms a dense atmosphere layer that blocked sunlight from reaching Earth. This phenomena is known as impact winter. Now, why is this so critical? Because sunlight is the foundation of almost all the life on Earth. Without sunlight, plant cannot perform photosynthesis. Plant life begins to die. Herbivores lose their food source. This creates a chain reaction collapse of entire food web. Large dinosaurs, which required large amount of food and energy, were the first to be affected severely. They did not die instantly, but they slowly starved as ecosystem collapsed. So while the asteroid impact is leading explanation, it was not the only environmental stress at that time. In India, the massive volcano eruptions known as Deccan traps were actively releasing lava and gases. These eruptions contributed large amount of carbon dioxide into the atmosphere, long-term climate fluctuations, additional environmental stress on ecosystems. Instead of single cause, many scientists now believe extinction was the result of multiple combined factors, as asteroid impact triggering immediate collapse and volcanic activity worsening long-term conditions. One of the most interesting part of this extinction is that not all life disappeared. Small animals had a better chance of survival because they required less food. After the extinction event, Earth slowly began to recover over millions of years. With large dinosaurs gone, ecological space opened up for mammals to diversify and evolve. Forests regrow, ecosystems stabilized, and new species emerged. This extinction event, although catastrophic, actually reshaped life on Earth and eventually made conditions suitable for human evolution much later. The extinction of dinosaurs was not simple failure of species. It was a planetary scale transformation triggered by an asteroid impact, intensified by volcanic activity and followed by global ecological collapse. And perhaps the most important lesson from this event is this: even the most dominant species on Earth are not immune to sudden planetary change. That's for now.